Blender 3D is a computer program for 3D graphics and animation, also known as computer-generated imagery, or CGI. This tutorial explains the basics of navigating Blender and is intended for absolute beginners. Let's start. Blender has a flexible user interface. In other words, the user interacts with Blender through a number of resizable, interchangeable windows. There are several preset layouts visible at the top of the screen. However, further flexibility can be gained in a few ways. First, individual windows can be changed via the Editor Type selection menu in the top left corner of every window. Additionally, the windows can be resized by dragging the border between them. Furthermore, windows can be split by dragging a corner inward in either the X or Y direction. Lastly, windows only of like dimensions can be joined by dragging a corner outward in either the Y or X direction.
Let's talk about how to navigate the 3D viewport by zooming, panning, and rotating. There are two methods to accomplish these tasks, and the first one assumes that you have a 3-button mouse. Let's start by zooming in and out on the default cube. This is done by scrolling up and down using the scroll wheel. Next, we want to know how to rotate around the cube. This is done by clicking and holding down the scroll wheel and moving the mouse around. Finally, panning around the screen is accomplished by holding down the Shift key and the scroll wheel at the same time and moving the mouse around. Knowing how to move around in 3D space is essential to working with computer-generated graphics, as you need to be able to work from all angles in the 3D viewport. Now let's talk about how you can navigate the 3D viewport in the event that you do not have a 3-button mouse, like if you are using a laptop. Look at the top right-hand corner of the 3D viewport at these two buttons and this set of axes. These tools are called gizmos, and they help us to zoom, pan, and rotate the perspective view without needing a dedicated mouse. Try clicking and holding on the gizmo that looks like a hand and moving your mouse pointer around the screen. You will notice that this mimics the pan function. Now, do the same thing on the gizmo that has a magnifying glass and a plus sign. This will zoom the viewport in and out. Finally, click and hold anywhere within the axes and move the mouse around. This will rotate the viewport.
There are three main types of objects in Blender: cameras, lamps, and meshes. Let's make an analogy to the real world. Your eye is like a camera, the sun is like a lamp, and the table in front of you is like a mesh. The sun emits photons, which travel to your table and bounce off of it, or scatter. Some of these scattered photons make their way to your eye, where they are perceived as color, shape, and size. In Blender, the lamp emits rays, which can be thought of as photons that exist only as paths defined by mathematical equations. These rays scatter off of meshes, and some make their way to the camera. When enough of these rays are caught, their color data is output as the rendered image. In general, meshes are modified to create different objects, lamps are modified to change how the meshes are lit, and the camera is not so much changed as moved to shift the perspective from which the meshes in the scene are viewed. There are a variety of mesh primitives from which objects are created. This is typically done through hard surface modeling in edit mode, which treats the object as a collection of vertices, edges, and faces, or sculpting in sculpt mode, which treats the mesh as if it's made of deformable clay. However, we will look at some simple ways to distort these primitives, namely transforming, rotating, and scaling. Transforming moves an object through 3D space. Rotating revolves an object about a user-defined axis. Scaling changes the size of an object. In a similar way to how there are two ways to navigate the 3D viewport, there are two ways to perform these actions. The first one uses options from the toolbar. Selecting the Move widget adds colored arrows and planes to the selected mesh. Clicking and dragging any one of these arrows moves it along the corresponding axis. Clicking and dragging any one of these planes moves it along 2 axes. Clicking and dragging outside the object moves it in the viewing plane. Selecting the Rotate and Scale widget have comparable effects. The other way to perform these options uses hotkeys. G, short for grab, allows for transformations in the viewing plane. However, movement can be constrained to any axis by pressing X, Y, or Z, or to a plane excluding an axis by pressing Shift plus the excluded axis. R accomplishes rotating, and S accomplishes scaling with similar optional axial constraints.
Another fundamental aspect of Blender is texturing your meshes. These can be anything from a simple solid color to a complex UV unwrapping of an image. But let's start by changing the color of the default cube. First, select the cube by left-clicking on it if it isn't already selected, highlighted in a bright orange outline. Then, navigate to the Material tab, which is marked by a sphere with a checker pattern. Next, click on the base color to change it. You will see a color wheel appear. Click and drag around the color wheel to change the color. I'm going to set the cube to a nice blue color, but you can set it to whatever you want. You will notice that the color of the cube has not changed in the 3D viewport, but that is because we are currently in solid rendering mode. To see what the cube will look like in our final render, click on the Rendered View button, which is the rightmost option in the header region above the 3D viewport. The viewport will now show a real-time rendered version of your object with the color you selected. There are 2 main render engines that Blender uses to render an object. The one that we are currently using is the default engine Eevee, which is similar in principle to a common game engine like Unity in that it takes shortcuts with lighting in order to decrease the time required to render each frame, which is why we are able to view the full quality of the rendered cube in real time, even when we rotate the view, for instance. Eevee is useful for any projects that don't require photorealism, such as a long-form animated series which needs to be produced efficiently, or a generally low-detail image, such as low-poly art. However, you can also use Eevee as a test engine to get a basic idea of how something would look with a material while you model or animate, then do the final render using the second main engine, Cycles. We can switch to Cycles by navigating to the Render tab, which looks like a camera. Then, click on the Render Engine drop-down menu and select Cycles. You will notice a difference in how the cube is rendered. For one thing, it will look a lot more grainy. This is because Cycle is designed for photorealistic renders, using ray tracing and light samples to calculate realistic light paths. Cycles is more useful when you want to produce lifelike images and animations, and it is proficient enough that you can create objects that look real and place them in a photo. The more samples that you tell Cycles to render, the more detailed and less grainy your render will be. The default number of samples in the viewport is 32, and in the top left of the viewport, you can see the path tracing samples loading each time you move around the viewport.
Now is a good time to talk about saving. From the File menu, click Save As and give your project a name. Make sure to preserve the .blend file extension at the end of your name. Then, navigate to the desired directory and click the Save As Blender File button. While the project is saved as a .blend file, images and animations must be saved as JPEGs, PNGs, AVIs, MOVs, etc. This is accomplished through a type of exporting called rendering, which is just the process of simulating and collecting mathematical rays described earlier. To render an image, go to the Render menu and select Render Image. This will export an image of the meshes from the camera view as lit by the lamp using the selected render engine. This image can be saved from the Image menu in the pop-up window. Rendering animations will not be covered in this tutorial, but are covered in our 2.8 Text with Bright Background Light tutorial. Thanks for watching. Please subscribe and leave a comment.